Welcome back. It is time to go on an emotional journey with Phil talking about passwords. Phil is a developer evangelist for Twilio and a Google developer expert living in Melbourne, Australia. He loves building web applications and tools to help developers. He once helped build a website to capture everyone's favourite sandwich fillings, and he has way too many GitHub repositories. Away from the keyboard, Phil listens to ska punk, hangs out with miniature Dachshund Ruby, and is on a mission to discover the world's best beers. If you find any good ones, please tell me. Over to you, Phil.
Thank you very much. Yes, I want to hear about all the best beers, and I don't think I have time, sadly, in this talk to get the dog on screen. But yes, let's take an emotional journey with a capital letter, a number, a special character, an emotional journey for that character, a subplot, and a twist ending. This might be the longest talk title I've ever written, but I think I'm in love with it, mainly because it's not even my joke, but we'll get to that later. As we started with, my name is philnash. I'm a developer evangelist at a company called Twilio. Twilio, if you don't know, is a communications platform. That is, we're an API that you can use to do almost anything you want to communicate with or between your users, from text messaging, voice calls, emails, all the way up to video chats and full contact centers. Twilio has something for that. If you do want to find me online, if you want to ask me questions either about this talk or indeed about Twilio, I'm basically philnash all over the place, but particularly at Twitter. Or just drop me an email, philnash@twilio.com. So let's talk about passwords, because that's what I'm here to berate, I guess, today. But I want to start with a bit of a story about my own dealings with passwords, because I've been mostly terrible over my lifetime usage of computers. And indeed, my first password was approximately the least secure password one could ever imagine. Now, this admittedly was the first time I ever had a computer account on a machine that wasn't mine. I was at school. I think I was maybe 12 or 13, and choosing that password to log into the computer system at school. And I picked the password Nash. Yes, my last name in all lowercase. A good 4-character long password. I like this. I was delighted with this. I was really quick at typing it because it was also part of my username. I'm sure everybody else has similar kind of first password stories or terrible passwords. And if you have a terrible password that you no longer use, please do share it in the chat. I'm keeping an eye on watching that as well. I'd love to see the terrible things you might have thought were a good password at one time. The second password was not better, actually. I did get hacked, and I'll talk more about that in a moment. And so when I changed my password, I changed it to, apparently I was geeky and into, I guess, chemistry at the time, and changed it to Atom. Still 4 characters, still all lowercase. But that one actually stayed secure for the remainder of at least my usage of it. But yeah, I got hacked. My friends, of course, got into my account, and thankfully, like, because I was 12 or 13, because there was barely any email at the time, because there was barely any internet at the time, there wasn't a lot that they could do to damage my account, reputation, bank balance, I guess. There was nothing they could do, but I learnt, well, I didn't really learn a lesson. I used a second terrible password, but I certainly learnt that losing access to an account because a password is compromised is totally worse. There we go. Dog is a terrible, terrible password. Thank you. That's amazing. One less character than I managed to fit in. Impressive. Thank you for sharing. These are great. I love this. The stars also. Love it. So the problem is, of course, passwords are terrible. We know this. We all instinctively know this as developers and people that care enough about security to be here at a security track at a conference. We know this, but we also know that we have probably a whole bunch of users that also like to make passwords with systems that we build. And so whilst we probably can now make better passwords than those original ones, oh my goodness, ABC123S. The S is really throwing things off there. We have to create systems in which users also end up using passwords. And how can we make that better? Well, one way that we don't make it better is via the guidelines. And this is where my talk title comes from, and really comes from a hilarious tweet from a long time ago. The idea that your password must contain at least 8 letters, a capital, a plot, a protagonist with good character development, a twist, and a happy ending. I love this because these guidelines, we've all seen them, we've all had to accommodate them at some point in our creation of passwords, right? We need an uppercase, lowercase, number, and a special character. One of everything. Get a whole lot, you win passwords. Congratulations. Here's a password that won't pass that, and it's not a great password. I mean, it's double the number of characters that I like to use in passwords, but still not a great one. But this one is a great one. It's superb, strong as anything, can't be beaten. It's got a capital letter, it's got a lowercase letter, it's got a number and an exclamation point. What a special character. Incredibly special character. Probably the one we'd all think of when you first think of writing a special character. It's under number 1 anyway. It's next to the number we'd all put at the end of that password in the first place. And this is the problem. This pattern is kind of indicative of how everybody, when given those guidelines, starts to think about their password. You capitalize the first letter in that word you thought of, you stick a number, normally 1, on the end, you stick a special character, normally exclamation point, on the end of that. Passwords that end with a bang, exactly. It's an exciting password, it's a secure password, we know this. And then further, those guidelines start to suggest that you change those passwords regularly. And you're like, well, I already spent a lot of time thinking up this one and getting it to the stage in which it was super secure. So let's keep that security, let's keep it all in mind and just add like a number, I guess. Or maybe another one. Like this kind of having to write new passwords just begets the same pattern over and over again, possibly similar to those old ones. And this is a pattern. The problem here is really the pattern. It's not actually the word password that I've been using in this fake password here, but the pattern. Because this, to any attacker, really just looks like this. It's an uppercase followed by some lowercase, possibly making up a dictionary word with a single digit and then a special character. And if we have those passwords, we didn't expand the number of potential passwords we had by adding these requirements. We actually shrunk it down. The attack space became a lot easier because we have just a pattern to attack, and it's horrifying. So, I have an example. Because back in 2018, there was an audit, a security audit of the WA government, and employee accounts, and they assessed 234,000 passwords, which is a pretty good, assessment of various people working in amongst the government. And a quarter of those passwords are deemed weak passwords. Now these, I don't know what necessarily these passwords were accounts for, but these are people working in government, so probably somewhat important and to do with people. Yeah. We can see, however, because they published the top 20 passwords, and number 1, of course, was password 123, which is glorious. 1,464 people in the WA government used the password 123. And then they published that top 20, so we can have a look and see all the patterns that are there. Now, we can also tell that the WA government did not require special characters because no one used one, not in that top 20 anyway. But we can see all of the patterns that are there, all of the dictionary words that start with a capital and end in numbers. Some of those numbers are dates, right? We've got the year 2017, the last time they were made to change it clearly. And in fact, you can imagine that maybe a whole bunch of people started at the same time and were told kind of similar things, so they all put welcome 1 as their password, or maybe they all hit that they all hit their password reset then in August 2017, previously having seen it in maybe spring 2017 or October 2017, and people are just looking around their office trying to think, what am I going to make a password out of? They spot the calendar on the wall and like, it's Monday. That'll do. It's the first Monday. It's spring 2017. They look down at their desk and there's a mouse there and it says Logitech on it, and that's the password. And this is the extent to people kind of taking those guidelines and turning them into passwords that we can then go ahead and guess as best we can. So, I want to tell you a little bit more about what I thought was my best password. Now this one is a password that lasted with me for quite a while. I don't, as far as I know, actively use it anymore, but I'm not going to tell you exactly what it is, just in case there's something out there. But I will tell you a little bit about it. It had 8 characters. You know, I did up from the 4 of my previous favourites. It was 8 characters long. There were numbers and letters in there, but not special characters. And actually not lowercase numbers, no lowercase letters either, uppercase only. And it was the model number of my hi-fi. Yes, and I was still relatively sort of young at this point, but I did look around my room and see a hi-fi there and just be like, all right, cool, what's the serial number? What's the model number on this? Can I remember it? It's 8 characters and it's made of numbers and letters. It'll do. But this was great. Like, it didn't... Nobody stole it by seeing me type it into a laptop, type it into a keyboard, and break into my account that way. But, of course, I did eventually get hacked. And this time around, it's not because it wasn't a decent password. I don't think anyone's ever going to guess it. But it was down to repetition. Because, of course, I was so proud of this password, so just genuinely delighted with how strong I thought it was, that I used it everywhere. Every single account, whatever, it was the same password. And of course, unbeknown to me, the security of applications and websites on the internet were not quite as strong as I'd have thought they were. And over the years, we've suffered many breaches of password data, username and password data. You know, some where the password was stored in plain text, which is horrifying. Some where it was just stored with a fairly breakable hashing algorithm. And so my username and password has leaked out many times from at least some of these big ones like Adobe or Dropbox or Bitly, Last.fm, LinkedIn, Discuss, Tumblr. There's been so many since I put some logos on a slide and did this. I think mine particularly were leaked out of, I think, LinkedIn and maybe Last.fm. And I lost access to other accounts. I lost access to, in one day I lost access to a Skype account and Spotify account. And I nearly lost access to a Dropbox account. So I know it wasn't that breach that caused this issue. But the Dropbox account, I know I nearly lost access because I got a text message with a 2-factor authentication code in it. And I did not text that on to anybody else. So 2-factor authentication saved me there. But on the same day, yeah, I lost Spotify and Skype. Now I imagine I managed to get both of those accounts back eventually. But some, you know, like the Spotify account was fine, but the Skype account had been used for some genuinely odd things, in which I actually ended up, I got really scared of the whole thing because I deleted all the kind of text conversations that had happened in my Skype account since I'd lost it. And it turned out that whoever was doing it was behaving as a French woman, kind of proposing to French men from my Skype account with my username. Very, very odd. But I managed to get it back and stop all of that, and hopefully the Frenchmen did not get scammed out of whatever they were being scammed with. So if you don't already know, the way to deal with this and find out if you've been in a breach, if you have lost your username and password, is to hit up Troy Hunt's haveibeenpwned.com, stick your email address in there and find out. Now that's great for you, but again, we're people watching a security talk. We probably are using different passwords in different places, and this is not super great necessarily for our users. So how do we fix all of this? This is the real important part. I've told you my terrible password stories, and those password stories are probably the password stories of our users of our applications as well. So how do we fix it? Well, first up, the guidelines were wrong. I'm really excited about that. The guidelines, I think the guidelines that most people followed in order to make those like uppercase, lowercase digits and special characters were written originally by NIST, the National Institute for Science and Technology in the US, who are good at that kind of thing. And they were wrong, right? They led us to this kind of thing. If we've not seen this XKCD comic, then it is glorious. And even the example in our top left panel here of of this password, which is pretty secure. It certainly doesn't fit the pattern I was talking about earlier. This is more throwing in leet text by changing O's for zeros and A for 4. Still includes, maybe the number and the punctuation are at the end there. But right, it does not take a long time to crack one of these passwords. And if we'd just been doing really long passwords, passphrases, then we'd have much more secure passwords. And so those guidelines did change, and NIST updated their guidelines in 2017. But most of the kind of English-speaking world's security forces, so NIST is in the US, ACSC is the Australian Cybersecurity Centre, and the NCSC is the National Cybersecurity Centre that's in the UK. Two countries just using national to mean them. It doesn't really work. But the UK, Australia, and the US all have published new guidelines, mostly following NIST, although NIST actually suggests at least 8 characters. It's Australia that says at least 14 characters, and I like that. And I think if we're building applications which require users to have passwords and we want to validate those passwords to be somewhat secure, making them at least 14 characters could be the best takeaway from this or any talk about passwords. So making at least 14 characters, accept all characters. I think we should have more emojis in passwords. Don't tell anybody what emojis you're using in passwords, but you shouldn't have to be held back to any kind of ASCII-based character set or anything like that. Accept all characters, including spaces, emojis, and crazy things. Not crazy, you know what I mean. And then don't allow insecure passwords. Insecure here has a bunch of meanings. For example, dictionary words. That's a relatively straightforward one to stop having people using. Then repeated or sequential characters, as somebody pointed out, U, L, 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 D, S is too many repeated L's there, so wouldn't pass as a password under this circumstance. No context-specific words, so not the username of the user, not the application name or the email address that they're using. And then finally, passwords that have been in a breach. Do not allow passwords that have been in a breach. This is a big one. So how do we do this in Python, and what have we got available to us in Python to do this? Well, I had a little look around kind of popular frameworks and how this is dealt with, and Django has a really good start to this, which is nice. A lot of the time I actually work with JavaScript and Ruby, and there is nothing like this in terms of a good default set of password validators that are available to you. Although I say that, like these password validators in Django, so we have user attribute similarity validator, so that is not the same as your username or your password or other attributes in the user model. Minimum length, which of course you have to set, and I say 14. Common password validator is checks against a list of 20,000 common passwords, which is very good. And the numeric password validator is just, it's not all numbers. Now these validators are available in Django, but they're not actually on by default, but you can just add them in by default. So I think that's really cool. I think it's very cool. Then there's things like WT Forms, which seems popular amongst Flask, has some validators available to it. But again, if you just whack in that length min 14, then we're going to make things mostly happy, I reckon. Yeah. So any suggestions on this? Just to enable all those Django validators, they're great. Or if you don't have that, make your password at least 14. And finally, my final recommendation is a library called ZXCVBN. It seems maybe hard to remember this one, but if you look down at your keyboard in front of you, you'll find if you're using a QWERTY keyboard, that's just the first 6 characters of the bottom row. It's actually really easy to remember, and it makes it a terrible password. So don't use it as a password. But I really love ZXCVBN because of what it can tell you about a password. And it works with that kind of idea of entropy rather than just length or filling in those guidelines. So I'm gonna start to use ZXCVBN just to have a look at a couple of passwords. If you have any passwords you want checked through this, drop them in the chat and I'll see them in about 30 to 40 seconds. Meanwhile, I'm just going to import from ZXCVPN, import ZXCVPN. Why? And just check my favorite go-to. Let's just start with password 1, and have a look at that. So ZXCVPN gives you a load of information about this. For a start, like the number of guesses it might take. In this case, it's guessing about 379 guesses before you get this. It tells you that it's a dictionary word, which is cool. And excitingly, it kind of tells you some display times that you can show for like how long this will take to crack. And so if you were trying passwords at 100 per hour, password 1 will be cracked in about 4 hours. But if you can do that real fast, it's going to be less than a second. And then finally, and really, really usefully, it also gives some feedback for users as well. So this is a common password. Here are some suggestions. Add some more words. Capitalizing the P wasn't particularly helpful. Password dogs. That's not going to go too well. Is that capital S for capital security? Again, similar to password in this case. We've got a dictionary word. It's going to take a day this time if you can only do 100 passwords an hour, and then 4 minutes at 10 per second. It's very common. Add another word. More words are better. What do we? Chat has run away. Oh my goodness. Line of ducks. So ZXCVPN is sweet for this. There is a web demo. Thank you for sharing that, Matt. I like to check other things. It also has what I wanted to point out was there's a score, and the score goes from 0 to 4, where 4 is the strongest. And so 4 is the kind of thing you're trying to drive people towards. Really simple things like hello is a score of 0. I think dogs with a capital S there came as a 1 because at least there was a capitalization in it. But if we want to get to strong ones, we start using those passphrases like correct, horse, battery, staple. Not a password you should use, but look at that. Score is 4. It's going to take centuries to get anything that long. And I'm excited about that. So ZXCVPN allows you not only to check passwords in a sensible manner, it actually gives you great feedback to your users to see why a password failed and help them get a better password. So what about insecure passwords? This kind of ticks off the guideline problem, but what about those insecure passwords that we talked about? Well, I mentioned Have I Been Pwned, Troy Hunt's service for telling you whether your email has been pwned, but that also exposes an API known as the Pwned Passwords API that has 613,584,246 passwords that have been previously exposed in data breaches. And so we can use Pwned Passwords to check whether any of the passwords our users are trying to use with us have been previously exposed in data breaches. Have been exposed in data breaches. And it has an API. Now you might be wondering, aren't we just going to breach a whole bunch more passwords if we start slinging passwords over the network to another API? But don't worry about that. The API is a bit more sensible than that and uses what is called a k-anonymity model to not expose the password, not share passwords over the network. So what you do instead is you get the SHA-1 hash of the password you want to check. You take the first 5 characters of that hash and then use that in the API request within the URL here. So it's under a range with that 5-character prefix. And back from that, you receive all the hashes that start with those 5 characters. You receive the remainder of all those hashes and then counts of those to show how many times that has appeared in the data set itself. And so you check if the remainder of your hash is in this result, and at that point you can say this password has either been breached or hasn't, which is pretty cool. And there's a Pwned Passwords library, of course, available in Python. And we'll go have a look at that right now. Now, I just noticed that, yeah, I got the wrong password. It was dogs. Dogs with a capital, the exclamation point. And thankfully, that's going to take a little bit, like still only a score of 1 for the, and if it was dogs with a small s, oops. Yeah, no, it's going to take days. Days, if you can only do 100 per hour, still less than a second, because it's just words. So again, I'm now just gonna get the Pwn passwords library in. Import. Oops. And now we can do things like check those passwords. So we can check, for example, my first password again. I can check that. It's actually been a password 3,219 times, or been in breaches 3,219 times, which is horrifying that my childhood password has been used and breached that many times. Although it does prove that my second attempt was slightly better, with less than half the number of breaches. We had dogs, 152 times been breached. How about the capital? Well, dog with a capital S and exclamation point. Still not going to take very long to crack, but has not been breached before, which is nice to see. And if you were wondering why you shouldn't use correct horse battery staple, it has been breached 5 times. So some people out there are not only using the password correct horse battery staple, they're using it in places that lost access to all the passwords and gave it away. Horrifying, right? So that is the Pwn Passwords API. I highly recommend checking it out and using it to keep an eye on this kind of stuff. And like I said, there is both plain Pwn Passwords library and there is a Django validator as well. So you might want to replace, say, the common words validator in Django with the Pwn Passwords validator. And the common words validator actually generates its 20,000 words from the Have I Been Pwned dataset. And so it could be useful to try and use them kind of in collaboration. If you wanted to hit like the common words dataset first, and then if it's not in there, farm out to the API. But honestly, the API returns so fast and is fully cached in Cloudflare. It's pretty impressive. So it's quick and it's always up. Incorrect horse battery staple. Well, I want to check that now. Not there. Cool. That one's secure. Done. So I'm running out of time. But I would tell you that the next level beyond making sure these passwords are actually secure for all of your users is, of course, to add a second level of authentication, a two-factor authentication. I have that turned on in almost every account I can, and if I can, I do it via an app. If I can't, then via SMS is still better than not having a second factor of authentication at all. So think about that. And ultimately, my lesson for today is passwords are terrible, but not necessarily because those it's not necessarily users' fault. The guidelines have been terrible. But users are pretty bad at this. I'm pretty bad at this, although I've now got better and, of course, have my own password manager. But passwords are terrible, and not everybody does that. Password guidelines are worse, although the update to the guidelines made them better. So the next time you see somebody else telling you need a special character or a digit or an uppercase letter, tell them they're using out-of-date guidelines because they are bad. Make passwords longer. Again, make them at just at least 14 characters, and we're probably going to solve a lot of these problems for a lot of people. Check against those breaches and against dictionaries. Check those words against the Pwn Passwords API. It's actually a super useful and free-to-use API. And finally, implement two-factor authentication. Just make passwords less of a problem that way. That's all I've got time for. Thanks so much. Thanks for suggesting things in the chat. And for all your playing along with my terrible passwords. And enjoy the rest of PyCon.
Thank you very much, Phil. You have come right up to the time. So if anyone's got any questions, please do ask them in the hallway chat. Phil did say he's happy to answer any questions, and I'm sure you all have 100 different passwords you want to run through these two.
I just spotted Purple Monkey Dishwasher. Yeah, it's looking good.
We will be back at 4:15 Australian Eastern Time for our next talk. So enjoy your break, everyone. We'll see you shortly.